today's example, I'm just going to assume you don't really know much about this stuff, so we're just going to go through the basics. So we've got a particle moving in a straight line. So this equation is in terms of t. Okay, so x in terms of t, time. Very good. Okay, it's not projectile motion, it's just going, in a straight line. Okay, so you'll get pretty simple questions like this. What's the initial position? Now, what do we know at the start, at the initial position? What equals what? 0. Time equals 0, right? So write it down. T equals 0 at our initial position. So we sub in t equals 0. So 0 squared, take 4 times 0 minus 12 is negative 12. Now, if it's at an origin, any ideas what a negative number might mean? Let's say it's going left and right. What do you think the negative means? Negative probably means left. Or if we're going up and down, negative probably means it went down. Okay? Determine its velocity function and hence state its initial velocity. Describe its initial motion. Okay, so first part, how do we find the velocity function? We do the derivative. Okay? So the derivative dx dt or x dash in terms of t is what? We bring the power out the front, minus 1 from the power. This bit here, bring the power out, minus 1 from the power. You're left with that. So there's our velocity in terms of time. Any ideas how we find our initial velocity? The second bit of part B. Initial velocity. If you ever see the word initial, it probably means t equals 0, right? It's a pretty good assumption. T equals 0 or v t equals 0. We're left with what? Negative 4, right? 2 times 0 is 0, take 4. So the initial velocity is negative 4. Again, the negative represents something. It's not crucial for today's lesson, but just keep that in mind. So, I guess it is the third part of B. Describe its initial motion. The initial velocity is negative 4 meters per second. Okay, negative. Does it say anything about like direction in the question? It just says it's in a straight line. So the negative either represents down or left, most likely. Okay, the next bit, determine the time and position at which the particle is momentarily at rest. So at what time, what position is the particle at rest? So what does that mean, at rest? Any ideas? It's stopped, it's not moving. Okay, so that would imply what? The velocity equals 0. If it says at rest, that means the velocity equals 0. Okay? So we're trying to figure out at what time does the velocity equal 0. So using our algebra skills, 2t equals positive 4, t equals 2. So at 2 seconds, the particle has stopped moving. It's at rest. So we're going to sketch a graph. Everyone's favorite thing to do. We're doing displacement versus time. So time is the x-axis. What is the displacement represented? What's the letter x in this one? So it starts at negative 12. T equals 0, x equals negative 12, right? Then, any ideas how I could graph this equation? Any thoughts? So, we're going to factorize x. What's two numbers that multiply -12 add to -4? Okay, so if x is 0, t is going to be +6 or t is going to be -2. What about a turning point? Any ideas? We can look at the number in between these two. What's halfway between 6 and -2? 2. So our turning point, t equals 2. X equals, take 12 is -16. So at t equals 2, we've got our turning point. We've got our intersect, that axis. So we're going like that. Okay, so the purple line is the particle. Why did I not go on that side of the x-axis? You can't really have negative time, okay? Negative time doesn't really exist. Okay, any thoughts? What is the distance it's traveled to reach the origin? So it went from 12 to 16, which is what? How many meters? 4 meters. Then it went from 16 to 0 in this section of the graph, which is how many meters? 16. So the total distance is 4 plus 16, 20 meters. Okay. The last one, the average velocity and the average speed between 0 and 6 seconds. So how do we find average velocity, average speed? So this is where the distance displacement thing is coming in, right? Speed is distance divided by time. Velocity is displacement divided by time. Velocity is a vector you're caring about the direction. So like I said before, we are displaced 12 meters over 6 seconds. So that's why it's 2 meters per second. Our speed, we traveled a distance of 20 meters over 6 seconds. Okay. So that's 3 1/3 meters per second. Okay.